Hello everyone. Here back again with another video showing you how to test transistors transition frequency qualitatively in order to find out whether a given transistor is able to work at high frequency. So the reason why I'm making this video is, most of us buy transistor kits from online retailers, such as like eBay, Amazon, AliExpress, and a number of online retailers, and they sell like transistor kits like this, right? This one seems to be from IC Touch. I think I bought it off of eBay a while back, and for experimentation and things like that, it seems to be a nice source of varied common type general purpose transistors, right? With some specific ones, ones that are capable of working at a high frequency, so it seems, right? So if I'm just trying to open this one here and quickly take a look. Okay, so if you just open this up real quick, and you see that here seem to have quite a bit of selection of transistors, like the your general purpose 2N2222, 2N3904, 3906, right? 55, 51, and things like that, right? And some like high frequency transistors like this one here, S9018, right? We buy these kits, but how sure are we that whatever this part number that's marked on these devices is what it really is, right? Especially when it comes to high frequency operation. Like, for example, this transistor seems to have a transition frequency between 700 megahertz to up to 1.1 gigahertz typical transition frequency. In fact, if we look at a data sheet here real quick, sorry for the flashing of this screen, but if we look at it, and actually one of its selling points is high current gain bandwidth product, FT equals 1.1 gigahertz typical. So how do we know if this is that transistor, right? So we can use a simple oscillator that we can build that is capable of oscillating at high frequency. Basically, this is a test setup, and I have it built here. In fact, actually, you can see it is oscillating, right? I'm measuring it with 3 of my scopes, one with high bandwidth, and this one with relatively 100 megahertz scopes, one with a lower sample frequency. Basically, and you can see that it's oscillating about 90 megahertz, and we'll take a look what type of transistor that is, whether that's a genuine one or not. So basically, if I quickly describe the circuit, is that this is a common base Colpitts based oscillator, and in fact L1 and C1 are not that critical, so you can use any sort of chokes or inductors you have with any capacitor value between a few picofarads to few microfarads. This is not critical, so you can replace them, and I've actually tested them all the way from 200 millihenries down to 4.5 microhenries with varied series resistance on the inductors. So basically, you can set this up and put your transistor there and test it. In fact, this arrangement seems to be heavily dependent, the oscillating frequency seems to be heavily dependent on the transistor that you're actually putting in on this circuit, not on the external values, right? So except for this feedback, this positive feedback capacitor here, it has to be very low value so that it couples the output back into the input, only a portion of it, right? So, and I've done few testing with genuine transistors like the 2N5551 that seems to oscillate around 51 megahertz. And if you actually look at its data sheet, it doesn't have relatively high transition frequency. We've got the MPSA 18, seems to oscillate around 84 to 90 megahertz, which I'll show you in a second. And these are all genuine transistors from name brand manufacturers, right? Like Motorola, National, and Fairchild, right? So, and the S9018 that I have, the real genuine one, oscillates about 147 to 150 megahertz. So one identifying mark that I've noticed, the ones from eBay, these transistors from eBay or the online retailers, the leads, right? If you look at the leads seems to be made up of some sort of ferromagnetic material, maybe some steel or some iron coated with silver or something like that, right? And in fact, you can test that. You know, here's my my magnet here, and if you look at these guys, they all go like, you know, just these, obviously some ferromagnetic materials on the leads, right? So I'm just gonna have a hard time now separating these guys. Yeah, but here I have another set of transistors. These all came from this guy here. These all came from that guy. And I have another set here from my stash here, all genuine, right? And have a look at these guys. None of these get picked up. Actually, one got picked up. So this is actually from this bunch here. So it's sneaked in. But you can see that these guys, you know, I can't pick any of these guys. Well, so this is just stuck in there. But you can see that, you know, I can't pick these guys up. So it looks like the leads is made up of copper, or, you know, copper or something like that, or, you know, aluminum or something like that, right? So I can't pick any of these guys, but these guys, there you go, right? You know, so definitely some identifying mark, right? You know, so that, you know, you don't get from name brand manufacturers, right? So yeah, so the one that I'm testing at the moment is, if you take a look, I believe that is, I don't know if I'm capable to see that. Let's take a look. That one is KSP44. It's a genuine transistor from a name brand. I hope you can see it. Just give it, yep, so you can see it. Yeah, KSP44. And it's oscillating right now at a 90 megahertz, right? So 90 megahertz, right? You know, with some peak-to-peak value, a decent peak-to-peak value with a decent RMS output, right? So, and you can see my frequency counter actually agreeing with that, right? 90.9 megahertz, right? So does my Rigol oscilloscope, right? Right there, right? So now what I'm going to do is I'm going to take this transistor here, this S918, and test it, see what frequency it oscillates at. And as we saw it, right, you know, it has a high transition frequency, right? So let's take a look at that. Okay, so if I just quickly grab it, and I actually am curious to pass it through this one of these testers that you get on eBay, and I'm just gonna put it here, and I just want to see how much gain it has. It's supposed to have high gain as well. Has a gain of 189, right? So what does the data sheet say? Okay, data sheet says, you know, depending on the marking, I believe my marking is, what's the marking on this? So if you take a look at this real quick, says it's R, right? Or H, is it? It says H. So if we look at H, it's somewhere around here, right? So if we take a look at it, so 97 to 146, right? So anyway, it's in there, right? Same transistor, it's in there, right there. And then if we look at it, it actually oscillates at 84 megahertz, right? So definitely this is not a high frequency transistor, right? So it looks like to me what they're doing is they just get one transistor that works relatively okay, and then they just slap on whatever part number they want to on it, and then you can sell it at whatever, right? So it's just, this look like varied transistors with varied characteristics, but to me it looks like it's just a single transistor, same type, and just slapped on with whatever marking they want to, right? That's what it looks like to me. In fact, some of my old transistors here, if you look at them, these old transistors, old school transistors, they have these nice marking, like, color marking at the back of the transistor, maybe supposed to signify something. Different colors, you see. And if you take a look at the part number, right, these are the ones that I tested with my magnet, and they were not picked up by the magnet. And you can see, right, they got some, these ones are from National, they got some National part number, right? And I believe I have another MPSA 19, I believe, right? So yeah, this one's to N4401, right? Anyway, so they have these, this one actually is marked with emitter base collector, if you see it, right? So this transistor has its pins marked, and it's, I think it's made by Motorola, and it's made by, it has emitter base collector. Okay, now we're gonna test the real I have it here, the real the S9018 transistor, and take a look at what frequency it oscillates. Just give me a second, let me put it in there. Okay, so it's in there, and you can see it. Actually, my Rigol scope is having a problem with it, right? It's reaching at its limit of its bandwidth, right? So you can see this one is saying, well, it can't, it's actually, what happened? Did it just get disconnected? Yeah, okay, there we go. I think, just quickly take a look, set this up. Okay, here it is. So I think it was loose connection, but anyway, so you can see it's oscillating. If we just increase the magnitude on this, it's oscillating around 145, 146 megahertz, close to 150 megahertz. You can see it's the transistor in there. If I move it, it might get disconnected, but it's in there, right? And just move this out of the way. My frequency counter is way, it's, say, over range, right? I'm using the 100 megahertz input, right? High impedance. I don't want to use the 50 ohm input because, it's going to load my circuit, right? My circuit expects a high impedance. So the only load on the circuit is basically the input of these three scopes. They're all in parallel with, the 1 mega ohm divided by, or 10 mega ohms, right? They're using 10 times probe. So the capacitance on those probes, and in parallel with the three 10 mega ohm series resistors, right? So anyway, so that doesn't seem to load my circuit, but you can see that, this transistor is definitely genuine, and it seems to oscillate at a much higher frequency than, the one from here. So again, I'm making this is just to give you a way to test the transition frequency of your transistor qualitatively, right? And see the capability of the transistors you buy to work at high frequency if you play around with, HF or VHF type of circuits, right? So you can test them this way, right? So this is a circuit. Again, L1 and C1 are not critical. You can use any values, right? And C2 is critical. I'm using 18 PAF here. I don't recommend it going above 33 PAF. And yeah, so that's basically it. Just giving you ideas on how to test these transistors that you buy from online retailers, right? So don't trust what you see on these markings here. Of course, I haven't tested their breakdown voltage, their gain, They're actually the gain, if we just randomly pick up, you know, one of these transistors here, let's go the C2SC945. These all seem to have a gain around 300, right? They all seem to have similar gain, which kind of tells me that they are similar type of transistors. So if I put them here, this tester here real quick, yeah, that's the gain you get. Like, you test whatever, you pick one, you test them, they seem to be between 300 and 400 gain. Really nice gain, but they don't seem to operate, you know, at high frequency, although, you know, most of them oscillated around 84 megahertz, right? So okay, anyway, I hope you enjoyed this video. I hope you find it useful. Take care, and we'll see you next time. Bye bye.